This is section 4.1, part 4. And we are going to look at the form of the quadratic equation y equals ax squared plus bx plus c. So you can see we've added another term, our third term, and it's bx. In the previous example, we saw y equals ax squared plus c, and there was no middle term. Now we have a middle term. So, in previous examples, in order to identify the vertex, we simply had to analyze the equation, and then the vertex was easily identifiable. It was either 0, 0 or 0, c. When we add this middle term here, this bx, it complicates things a little bit. We can't simply find the vertex from just looking at the equation. We need to do a little bit of calculations, a little bit of math. So we must find the vertex. All right, it's not easily identifiable. So how do we do that? So in order to do that, let's take a look at our first equation here. So we see y equals 2x squared minus 8x plus 6. Before we go ahead and find the vertex, I'm going to ask you a question. Does this parabola open up or down? And how do you know? All right, does it open up or down? You should be able to see that just from looking at the equation. So, if you said it opens up, all right, you're on the right track. If you said it opens down, well, let's analyze the equation and figure out why it opens up. So remember, the a value is our telltale sign. All right, what's our a value? It's positive 2. And if you remember, if the a value is positive, your parabola opens up. That's why our parabola opens up, because this number right here in front of x squared, our leading coefficient, is positive. If it were negative, and you would have been correct, people who said it opens down. All right, so we'll come back to this. All right, after we graph, you'll see our parabola does in fact open up. So let's get back on track. Let's find our vertex. All right, so we see that down here. We're going to find our vertex. What are we going to do first? We need to find the axis of symmetry, which, if you remember, I've stated a number of times, is the x value of your vertex. Up until this point, that x value has always been 0. All right, but once you throw in this middle term, it will change things. The x value can be anywhere in your coordinate plane. It will no longer be 0. All right, so we need to find out what that x value is. So how do we do that? There's a little formula you're going to have to remember to find that x value. All right, we're looking for the x value, and it's going to be the opposite of b over 2a. To find our axis of symmetry, use the equation x equals opposite of b over 2a. If these letters are not making sense to you, let me scroll back up here. And what's the formula here? Oh, we got a, b, and c. So what's our a value? 2. That's what we're going to want to put in here. What's our b value? Negative 8. That's what we're going to want to put in here. So that's going to be our next step. We're going to identify what our a, our b, and our c values are. And we're going to write them down so we remember when we look back at our notes. So, alright, we'll put them right here so we can kind of see both parts in the window. So our a value is 2. Our b value is negative 8. And our c value is 6. So we're going to need that information to find our vertex. Alright, so I'm going to take this equation, x equals the opposite of b, which my b value is negative 8, over 2 times the value of a, and our value of a is 2. Now we want to simplify. So I have the opposite of negative 8 over 2 times 2 is 4. I have 2 negatives. 2 negatives make a positive. 8 divided by 4 is 2. So the axis of symmetry, or the x value of your vertex, is x equals 2. Once you find what x equals 2 is, alright, or once you find out your axis of symmetry and you see x equals 2, you're going to want to next plug this x value into the original equation to find your y value. And then we'll have the y value of our vertex, and we'll have our whole vertex. So we want to go back to the original equation, which was y equals 2x squared minus 8x plus 6. We're going to plug this value of 2 in for x. So since x is 2, what is y? Notice there's 2 locations for x now, so we have to make sure we're plugging 2 into both of those spots. Order of operations, well, there's nothing to do with parentheses. Next comes exponents, so I have to evaluate this exponent first. So 2 squared is 4. Then I look for multiplication and division. I have 2 instances of multiplication. So 2 times 4 is 8. Negative 8 times 2 is negative 16. Drop down the plus 6, and I do addition and subtraction from left to right. 8 minus 16 is negative 8. Plus 6 is negative 2. So the y value is negative 2. So I now have the coordinates of my vertex. It's this x value of 2 and this y value of negative 2. Those are the coordinates of my vertex. So I'm going to want to make a table, and as always, the vertex goes right in the center. So instead of 0 going here, the x value of my vertex is now 2. The y value of my vertex is negative 2. So I'm no longer going to use negative 2, negative 1, 0, 1, and 2. Alright, you're going to base your numbers that you're going to choose off of your vertex. So, and specifically off the x value of your vertex. So since the x value is 2, I'm going to go up 1 to 3, then I'm going to go up another 1 to 4. I'm going to go down 1 to positive 1, and down another 1 to 0. And these are the values of the x values of my parabola. So I need to now find the y values, so I'm going to plug in x equals 3 into my original equation, which was 2x squared minus 8x plus 6. So I've got, well, let me write the original equation down for you guys since it's not here. So the original equation looked like this: y equals 2x squared minus 8x plus 6. So we're going to find x equals 3. So I'm going to plug in. Actually, I'm going to find x equals 1. 1 and 0 is easier to deal with, easier to do math with. So we'll do 2 times 1 squared minus 8 times 1 plus 6. 1 squared is 1, so I've got 2 times 1 minus 8 times 1 plus 6. 2 times 1 is 2. Negative 8 times 1 is negative 8. Plus 6. Running out of room, so I'll squeeze it in over here. 2 minus 8 is negative 6. Plus 6 is 0. Alright, so when I have an x value of 1, my y value is 0. Since these two numbers are equal distances from the vertex, I know this number is also going to be 0. Now I'll plug in x equals 0 into my equation. So I see y equals 2 times 0 squared minus 8 times 0 plus 6. Zeros are going to wipe out both terms because 0 squared is 0 and 2 times 0 is still 0. Negative 8 times 0 is 0 plus 6. 0 minus 0 is 0 plus 6 is positive 6. So when I have I should start by putting this value over here, an x value of 0, my y value is going to be 6. So since these are equal distances, 2 units, these are 2 units, this value will also be 6. So I now have my table. I'll plot my points starting with my vertex. So I'm at 2, negative 2. Then I go over to 3, 0. 4, comma 6. So 1, 2, 3, 4, 5, 6. and I'm at net 1, 0, and 0, 6. So my vertex is no longer on the y-axis. It has shifted, and that's because of that middle term. So I still need to label my axis of symmetry, and remember it's that imaginary line that passes through the vertex. So I have my axis of symmetry here. And it has an x value of positive 2. It's the x value of your vertex. We also have a minimum value, and we have a minimum value because my parabola opens up just as we predicted. Because the a value is positive, we knew it was going to open up. So the minimum value is going to be the y value of your vertex, which is negative 2. Right? On the y value, the lowest it gets is negative 2. Alright, and that's part 4.